Hello everyone, good morning. How are you today? Hello, good morning. So am I audible? And can you see my screen? Okay, thank you for responding. Okay, so let's start with our today's session. So today's topics are redox reaction and electrochemistry. So these two topics are very, very important because on redox reaction, there is a questions which is asked, which is depend upon determining the oxidation number, or there are certain questions in which we have to find out whether the reaction is disproportionation reaction, whether which type of species is undergoing into oxidation and which type of species is undergoing into reduction. Like that way, there are good type of questions are asked from redox reaction chapter. And when you talk about electrochemistry now, in electrochemistry, you must have seen that there are certain reactions which takes place, like at anode oxidation takes place, at cathode reduction takes place. So that's why these two chapters we have combined together here. So when you study redox reaction, you can relate it with the electrochemistry also, because electrochemistry consists of redox reactions. Okay, they consist of certain reactions which are occurring at a different electrodes. Okay, so that's why here we have summarized these two chapters together. Now let's start with our session. So first of all, I am going to start with the redox reaction PYQs. Okay, so first question you can see here, what is the change in oxidation number of carbon in the following reaction? So here we have given a simple reaction of CH4 reacts with what? Methane reacts with Cl2. So what is happening into the oxidation number of carbon here? When methane is there, it is getting converted into CCl4. Okay, what is the change in the oxidation number of CH4 to CHCl4? CH4 to CCl4. So what change you can observe here? You can see that there is a hydrogen attached to carbon. And when we need to find out the oxidation number, we need to consider which element is most electronegative here. So in between carbon and hydrogen, carbon is more electronegative as compared to hydrogen. And that's why carbon will bear a negative oxidation number and hydrogen will bear a positive oxidation number. Converse is the case here. Chlorine is more electronegative as compared to carbon, and that's why carbon will have the positive oxidation number here and chlorine will have the negative oxidation number here. So now in order to have these molecules to be neutral, we need here what? Here 4H plus means 4 hydrogens are present. That means if we don't know the what will be the oxidation number for carbon, so you can write X into 4, right, into plus 1. So what is the oxidation number for carbon here? -4. And here X plus 4 chlorines are there and their oxidation number is -1. So you can calculate here that the change in the carbon's oxidation state is from -4 to +4. That is your option number C. Any doubt in this? Simplest problem. See, such type of simplest problems can be asked. Okay. Okay. So should I go further? Okay. Should I solve next question? Okay. So next question. The correct structure of tribromo-octa oxide is. So here we need to find out the correct structure for tribromo-octa oxide. So you can see here there are 3 structures in which you can see in this second structure there is no charge. That is, this species is what? Neutral. So the tribromo-octa oxide is actually a neutral molecule in which the bromine is attached by 8 oxygen atoms. Okay, double bondedly attached to 8 oxygen atom, and they have BR-BR linkage also present. So this molecule is neutral molecule, you can see here, and that's why the structure, correct structure for tribromo-octa oxide is this one, not this, not this, not this. Okay, any doubt? Okay, next question. Which of the following reactions are disproportionation reaction? So first of all, what is the meaning of disproportionation reaction? So these are the reactions in which same element or compounds undergoes into oxidation as well as reduction simultaneously. What is happening? Simultaneously, the reduction and oxidation is going to take place in a one simple element or a compound. एक एलिमेंट का ऑक्सीडेशन भी होता है और एक ही एलिमेंट का रिडक्शन भी होता है, दोनों प्रोसेस होते हैं साइमल्टेनियसली. सो राइट नाउ वी नीड टू ऑब्जर्व द ऑक्सीडेशन स्टेट फॉर ईच एंड एवरी एलिमेंट हियर. व्हाट इज द चेंज? So first reaction, you can see that Cu plus is there, whose oxidation state is changing from +1 to +2 and then 0. So here, when oxidation number increases, what happens? Oxidation number increases, and when oxidation number decreases, what happens? Oxidation or reduction? Yes, when oxidation number increases, what happens? Oxidation or reduction? And when oxidation number decreases, what happens? Oxidation or reduction? Yeah, this is very, very important. Do you know this? So from Cu plus, it has been changed to Cu2 plus. So what has happened here? Oxidation number has been increased. So when oxidation number increases now, which type of process takes place? Oxidation. That is loss of electron. Okay. And again, Cu plus is getting converted into Cu0. Right? So here oxidation has been decreased, and that's why this is what? Reduction, that is gain of electron. Right? So here simultaneously oxidation as well as reduction has been takes place. That's why this is a disproportionation reaction. But in the option, there are multiple reactions which are showing disproportionation reaction. Right? So first reaction is in each option. So we need to find out further reactions. Okay. So next reaction is 3MnO2 minus 4H plus, giving 2MnO minus MnO2 and 2H2. Okay. So in this reaction, you can see the molecule. This was the first reaction and this was the second reaction. 3MnO4, 2 minus, manganese is in +6 oxidation state. And it undergoes change into oxidation state by +7 and in this compound by +4. So you can observe here, this is the increase in oxidation number and this is the decrease in oxidation number. Increase means oxidation hoega, decrease means reduction hoega. So here oxidation as well as reduction is taking place, and that's why this reaction is again a disproportionation reaction. Okay. When you observe next to now, you can observe that there is no such simultaneous oxidation and reduction is going to take place. That's why here our correct answer will be option B. You can do the calculation of oxidation number for next two reactions. You can deduce it by yourself and you can observe that you can check. Okay, you can check for these two reactions and you can observe that such a type of increase and decrease is not happening for the next reaction. Only increase or only decrease is happening in oxidation number. ठीक है, यहाँ पे ये दो रिएक्शंस में साइमल्टेनियसली इंक्रीज और डिक्रीज नहीं हो रहा है. ठीक है, एक तो एक में इंक्रीज हो रहा है और दूसरे में डिक्रीज हो रहा है. ऑक्सीडेशन नंबर की बात कर रही हूँ मैं. ओके, एनी डाउट इन दिस? ओके, shall we move on? Next question. What is the oxidation state of chromium in chromium O5? So this molecule, we must remember the structure of this molecule. Okay, and then only we will be accurately determine, we will be able to accurately determine the oxidation state for this chromium atom. Okay, present in this molecule. So this CrO5 has butterfly-like structure. So it has a butterfly-like structure. Okay, chromium like this way. Then oxygens are like this way. And this is what the head of the butterfly. Okay, oxygen, 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 oxygen. Yeah, this is the peroxy linkage present here. Okay, not peroxy, peroxo, peroxo. Okay, peroxo bonds are present here. 1, 2. Okay, these are the peroxo bond present here. And due to this peroxo oxygen, they contribute to the oxidation state by -1. They contribute to the oxidation state by -1. And that's why let's calculate the oxidation state for this. These are the peroxo and this is the double bond oxygen. So X, I don't know. These are the 4 peroxy oxygen plus this is what 1 oxygen with -2 oxidation state. You know, oxidation state for oxygen is what? -1. So calculate this X -4 -2. So this is equal to X -6. So what will be the value for X? 6. So this will be the oxidation state for our given compound. Right? C, plus 6. Any doubt in this? Right. Next question. Correct order of N compounds in decreasing order of oxidation state. So here we need to find out the correct order of nitrogen containing compounds in its decreasing order of oxidation state. So let's find out the oxidation state for each and every compound present here, HNO3, NO, N2 and NH4Cl. So when you calculate the oxidation state for nitrogen in each molecule, you can find out the order of decrease in oxidation state. So see here in HNO3, what is the oxidation state of central nitrogen atom? Here +1 for hydrogen. We don't know for nitrogen. Okay, I will write here. So you will be able to find out. Okay, +1 for hydrogen. Nitrogen के लिए I don't know. Right? Positive करो. 3 ऑक्सीजन है, तीनों का क्या होता है? -2. Right? यहाँ पे क्या आएगा? X plus 1 minus 6. That is x minus 5. So that is equal to x is equal to 5. Right? That is what x is equal to +5. So here +5 is the oxidation state. NO क्या होगा? X plus -2. So x is equal to कितना हो जाएगा? +2. Very good. N2 is what? Same diatomic molecule. Okay, homonuclear diatomic molecule. That's why its oxidation number will be 0. यहाँ पे देखो x plus 4 minus 1. यहाँ पे आएगा x plus 3. That's why x is equal to -3. So here -3. तो डिक्रीजिंग ऑर्डर में हमको अरेंज करने हैं. तो पहले सबसे ज्यादा, then उससे कम, then lesser and then very less. So first of all HNO3, then NO, then N2 and then NH4Cl. So that's why here order will be what? Correct option will be what? Option number A. So in this way, you should be able to determine the oxidation state for a given compound. Okay, you know how to determine the oxidation state? Yes, can you respond me? Yeah. Next problem. There are 2 reactions given to us. Okay, and we need to find out the role of hydrogen peroxide in the above reaction respectively is oxidizing in 1, reducing in 2, reducing in 1, oxidizing in 2, reducing in 1 and 2, oxidizing in 1 and 2. So first of all, let's consider both the reactions. So H2O2 reacts with ozone to give H2O plus twice of O2. So here we need to find out when is increase in oxidation state happening and when is decrease in oxidation state happening. Okay, oxidation state increases, that is what? It acts as a reducing agent. It acts as a reducing agent. And when there is a decrease in oxidation state or oxidation number, it acts as a, right? It acts as a reducing, oxidizing agent. Oxidizing agent. Okay, as well as we have talked right now that if increase in oxidation state is there, it is oxidation, and decrease in oxidation state is what? Reduction, right? So reducing agent is the agent which oxidizes other species and undergoes into reduction. Okay, so consider here both the reactions. H2O2 का reaction किससे हो रहा है? ओजोन से, उसमें H2O फॉर्म हो रहा है और twice of O2 फॉर्म हो रहा है. ठीक है, you can see here O3, it was initially into the 0 oxidation state, get converted into -2 oxidation state. Okay, so what has happened here? Decrease in oxidation state takes place. Okay, here in this molecule H2O2, its oxidation state was -1, it get converted into 0. To -1 to 0, there is an increase in oxidation state. That's why this is here. H2O2 is acting as what? Reducing agent. H2O2 here acting as a reducing agent because its oxidation state has been changed from -1 to 0. Okay, next in the second reaction, H2O2 is there, whose oxidation state, you know, it's a -1. When it reacts with Ag2O, here you can see, which is having +1 oxidation state, it is getting converted into what? Ag, that is a pure metal. So that's why its oxidation state is 0, and H2O and O2. So here also same case is happening. There is a increase in oxidation number in both the cases, in both the reactions. So when there is an increase in oxidation number or oxidation state occur, ON or OS you can call it as, okay. When that is happening, you can say that it is acting as a reducing agent. So यहाँ पे in both the reaction, it will act as what? Reducing. It will act as a reducing agent. So here H2O2 acts as a reducing agent in both the reactions in which O2 gas is evolved. In which O2 gas is evolved. Right? Any doubt in this? Okay, next question. The pair of compounds that exist together is, yeah. So which of the compounds which are can exist together? तो यहाँ पे हमारा आंसर है C. FeCl2 and SnCl2, they can exist together with low oxidation state. Okay, with the low oxidation state or with the low oxidation number. Okay, this pair can exist together. Okay, next. Okay, mixture of potassium chlorate, oxalic acid and sulfuric acid is heated. Okay, during the reaction, which element undergoes into maximum change in the oxidation number? So here I have shown the reaction of potassium chlorate. Okay, KClO3 reacts with oxalic acid, that is COOH, COOH. This is our oxalic acid. Okay, and H2SO4, that is sulfuric acid. These three are heated together. Okay, the reaction which element undergoes into maximum change. So we need to calculate the oxidation number for each and every species. So here you can see potassium +1, for chlorine it is what? +5 or -5? It is +5. Okay, because oxygen is more electronegative, and -2 for oxygen. So, and here sulfur is having +6 oxidation state. You can see here sulfur is having +6 oxidation state, chlorine is having -1 oxidation state. So who's undergoing into maximum change here? Chlorine, who is having +5, it has been changed to -1. So there is a maximum change in oxidation number observed for chlorine. You can easily calculate the oxidation number, right? X K के लिए क्या है? +1 है, क्लोरीन के लिए क्या है? +5 है, ऑक्सीजन के लिए क्या है? 3 ऑक्सीजन है और एक ऑक्सीजन का -2 होता है, तो 3 into 2, that is -6. So for balancing that, +6, +6 are also present. So that's why this overall molecule is what? Neutral. Okay, overall molecule is what? Neutral. Any doubt in this? You can easily find out the oxidation state, right? यहाँ पे K2SO4, KCl, K+ or Cl-. Huh? Okay. Oxidation number of phosphorus in PO4 3-, sulfur in SO4 2-, and chromium in Cr2O7 2- is. Yeah, can you tell me the answer? Very simple. See, oxidation number calculation questions are mostly asked on the redox reaction chapter. ठीक है, क्या होगा phosphorus का oxidation number PO3- में? So let's suppose we have given PO4 3-. It is what? PO4 3-. Okay, I will just rewrite it. Okay, PO4 3-. So let's assume that X is the oxidation number of phosphorus, because we don't know, right? And 4 are the oxygens, okay, which are having -2 charge. Okay, but overall charge on the molecule is what? -3. So I will write equal to 3. Later on in the previous questions we have seen that there were no any charges present. That's why I have taken equal to 0. Okay, but यहाँ पे charge present है compound पे, that is -3, and that's why in after the equivalent is equal to sign I have written here -3. Okay, so what will be the answer here? Yes, so X -8 equal to -3, calculated. X is equal to how much? You are going to get +5. Similarly, you can do for SO4 2-. इसका oxidation number X consider करो या फिर Y consider करो, you will get Y is equal to +6. For next compound, that is Cr2O7 2-, you will get oxidation number of it as +6. Okay, I will calculate. Okay, for the Cr2O7 2-. So there are 2 times of Z plus 7 times of -2 is equal to -2. So 2Z plus -14 is equal to -2. So it is equal to 2Z is equal to -12. So Z is equal to what? 6 plus 12. Sorry, ये इधर जाएगा ना, +6. So plus 5, plus 6 and plus 6 oxidation state. Plus 5, plus 6, plus 6. So option D is correct answer. Right? Option D is a correct answer here. Any doubt in this? Do you know how to solve the oxidation state problem? Yes? Okay. Next problem. The number of moles of MnO4 minus required to oxidize 1 mole of ferrous oxalate completely in acidic medium. Okay. Will be, how many number of moles will be required if we want to completely oxidize ferrous oxalate? Okay. So यहाँ पे देखो reaction मैंने लिखा हुआ है. Reaction क्या है? MnO4 minus MnO. Okay. MnO4 minus plus H plus. Okay. It is giving us Mn2 plus. Okay. 4H2O. This is one reaction. Okay. 4H2O. Another reaction is what? CO. Okay. C2O4 giving us 2CO2 plus 2 electron. Okay. और ये जो reaction है यहाँ पे involved है 5 electrons. Okay. Right? Any doubt in this? C2O4 2 minus. C2O4 2 minus will give like this way. So यहाँ पे 5 इलेक्ट्रॉन है, यहाँ पे 2 इलेक्ट्रॉन है. इलेक्ट्रॉन बैलेंस है क्या रिएक्शन में? नहीं बैलेंस है. So what we have to do? We have to multiply this equation by 2 and we have to multiply this equation by 5. Then you will get an overall reaction. Multiply this by 5. Multiply this by 2. What you will get? 5 into 2, 10 electrons. Here you will get, means just write it. Okay, rewrite it. You will get the reaction like this way. Here I have shown 2MnO4 minus. Okay, O4 minus 2MnO4 minus. यहाँ पे 4 ऊपर नहीं है. ओके, यहाँ पे 4 है नीचे. MnO4 minus. क्या MnO4 का? MnO4 minus. यहाँ पे प्रॉब्लम में भी दिया हुआ है. So यहाँ पे लिखो 2MnO4 minus plus यहाँ पे क्या आएगा अभी 5C2O4 2 minus. These are our reactant side, right? So यहाँ पे H plus को बैलेंस करो. यहाँ पे 8H plus थे. 8 into 2 are 16H plus. तो यहाँ पे मैंने लिखा है देखो 16H plus it is equal to 2Mn2 plus 10CO2 and 8H2O. So when you see here now 2 moles of MnO4 minus required to oxidize 5 moles of oxalates. Right? 2 moles of MnO4 minus are required to oxidize this 5 moles of C2O4 2 minus. So number of moles of MnO4 minus required to oxidize, how many moles we have asked? 1 mole of will be. So 1 mole के लिए कितना आएगा? ठीक है, कितने मुझे MnO4 required होंगे अगर मुझे 1 मोल का C2O4 2 minus oxidize करना हो. So your answer is very simple. Just do the cross multiplication. You will get X is equal to 2 by 5. That is 0.4. So your answer is what? Option D, 0.4 moles. Okay. Any doubt in this? Yeah. Next reaction. Which is the best description of the behavior of bromine in the following given reaction? Proton acceptor only. Both oxidized and reduced. Oxidized only. Okay. Reduced only. So here, let's consider this reaction, okay? H2O plus Br2 gives HOBr plus HBr. Here you can observe that H2O and Br2, okay? H2O, Br2, HOBr and HBr. So here Br2 is having 0 oxidation state. It is having +1 as well as -1. Okay, so there is an increase in oxidation state as well as there is a decrease in oxidation state. Increase in oxidation state means oxidation. Decrease in oxidation state means reduction. So bromine, what is happening to the bromine? It is undergoing into both, that is oxidation as well as reduction. So it is undergoing into oxidized species as well as reduced species. Okay. See, summarized here everything. Next, reaction of sodium thiosulfate with iodine gives tetrathioionate, sulfide ion, sulfate ion, sulfide ion. So see here reaction of sodium thiosulfate. What is sodium thiosulfate? Na2H2O3. This is our sodium thiosulfate. Its reaction with iodine gives us sodium tetrathionate, Na2H4O6. Okay, so answer is what? Tetrathionate ion. Tetrathionate ion. Okay, A answer. Next question. Oxide which cannot act as a reducing agent is, yeah, CO2, ClO2, NO2 and SO2. Which will not be act as a reducing agent? What is the requirement for reducing agent? Reducing agent. Yes. What is the meaning of reducing agent? Can you tell me what is the meaning of reducing agent? Yes. Very simple reaction. Very simple definition of reducing agent. What is a reducing agent? Which itself loses the electrons, right? Which itself loses the electron to other substance in the redox reaction. Okay, so it loses electron itself. वो खुद के इलेक्ट्रॉन्स क्या कर देता है? रिड्यूस कर देता है और वो दूसरे को दे देता है. ठीक है, in order to reduce another substance, it itself loses their electron. That is known as a reducing agent. Okay, so in order to oxidize, okay, so a substance which loses electron to other substance in a redox reaction and gets oxidized to a higher valency state, and in this oxidation number also increases in this process. So यहाँ पे CO2, ClO2, NO2 or SO2. So we need to find out the oxidation number of each and every element. When you find out that now, you will observe that the substance or element which is having highest oxidation state, okay, which is already having the highest oxidation state, will not behave as a reducing agent. Okay, so carbon here in CO2 molecule is already in its higher oxidation state, is already in its highest oxidation state. And what is that? +4. Okay, what is that? +4. So it is already in its highest oxidation state. So that's why it cannot get converted into more higher oxidation state than +4. And that's why it is not act as a good reducing agent here. It cannot act as a reducing agent. Other components, ClO2, SO2 and NO2, when you calculate the oxidation state for them, you will observe that they are not having the highest oxidation state. Okay, so carbon is in its maximum oxidation state. That's why that will be our answer. Next, which substance is serving as a reducing agent? Yeah, which substance is serving as a reducing agent? What I have told you right now, reducing agent means what? Which loses the electron, whose oxidation number increases, will be what? The reducing agent. So see here, reaction is given Cr2O7 2 minus gives 7H2O 2Cr 7H2O 2Cr3 plus and 3Ni2 plus. So what will be the answer here? H plus है और reducing agent Cr2O7 है, कौन है? H2 है और निकेल है. Which is the reducing agent here? We need to find out whose oxidation number is increases. Okay, so first of all, nickel was in 0 state. Here it is in a +2 oxidation state. So his oxidation number has been increased. So increase in oxidation number is what our reducing agent. So our answer is what here? Option number D. Any doubts? Yes. Next problem. Okay, tell me the oxidation state of iodine in H4IO4 minus. HiO4. H4IO minus. Yeah, what is the oxidation state of iodine? चार हाइड्रोजन से उनकी +4 आ जाएगी. आयोडीन का X लिख लो, ऑक्सीजन का -2, ओवरऑल मॉलिक्यूल पे है -1 चार्ज. तो यहाँ पे आ जाएगा X minus X plus 2 is equal to -1. So X is equal to -1. Right? X is equal to -1. Any doubt? Yes. Any doubt in this? बराबर है ना? ये गलत हो गया कुछ? Any answers? Yes. Yeah. So यहाँ पे क्या है? 6 है. 6. तो यहाँ पे 6 लिखो. 6 oxygen atoms है. Okay. Sorry for the printing mistake here. Okay. I will calculate the oxidation state again. Okay. HiO6 minus HiO6 minus HiO6 minus. Yeah. So see here, answer is what? Like this way. So 4 hydrogen X for iodine, 6 oxygen atom, and overall charge on the molecule is -1. So X is equal to what? +7. So what is oxidation state of iodine? +7. Right? Any doubt in this? समझ में आ गया सबको? ऑक्सीडेशन स्टेट निकालो. और कुछ जो स्टैंडर्ड एलिमेंट्स है, सम स्टैंडर्ड एलिमेंट्स, just remember their oxidation state. Hydrogen +1, oxygen -2. Okay, standard elements, chlorine -1. Okay, like that way, just remember their oxidation numbers, or you can call it as oxidation state also. Next topic our is electrochemistry. So you know, in electrochemistry there are different kinds of cell we study, right? Voltaic cell, electrolytic cell. So what is voltaic cell? At anode oxidation takes place, and at cathode what happens? Reduction takes place. Positive terminal, negative terminal. Okay, electrolytic cell, oxidation at positive terminal, reduction at negative terminal. So there is only change of positive and negative sign. At anode oxidation takes place, that is common. At cathode reduction takes place, this is also common. But in voltaic cell, it is a negative, which is a anode, and positive, which is a cathode, and converse for the electrolytic cell. Are you getting it? And how you will determine the electrode potential? E cell is equal to, right में जो potential हो जाएगा वो minus E left. Okay, very important equation, Nernst equation. Most of the problems are asked from the Nernst equation. If you have given a reaction, electrode reaction, okay, so you should be able to find out the E cell of that given reaction by using this formula. E naught cell is equal to 2.303 RT upon NF log of 1 upon Mn plus. So यहाँ पे क्या है? Product divided by reactant. So in product there was a atom in its standard state. That's why its concentration will be 1. And in reactant molecule, the Mn plus ions are present. So I have written them into the denominator. For a reaction, suppose we have a complete cell reaction given. Okay, so for complete cell reaction, see, reaction quotient we have written here, log of reaction quotient, that is product divided by reactant. Concentration of product with respect to their moles divided by concentration of reactant with their respect to moles. E cell is equal to E naught cell minus of 2.303. This is very important. If there is an equilibrium, E cell becomes 0. So this will become 0. So E naught cell will become like this way. And our log K, that is what? A reaction quotient will be equal to the equilibrium constant. Another very important equation, delta G is equal to NF E cell minus sign. Okay, if E cell is not there, you can write down for equilibrium condition E naught cell. Next, electrochemical series, you must be heard about this term. That is what? Arrangement of elements in order of increasing value of their E naught reduction. Okay, reducing nature decreases from top to bottom. So this is known as an electrochemical series. Very important question can be asked on this. Next, you know, conductance, electrolytic conductance, specific conductance, molar conductance. Okay, and how to determine degree of dissociation. And the degree of dissociation we calculate most of the time for weak electrolyte, and the formula for those are like this way. ओके, डिसोसिएशन इसका फॉर्मूला ऐसा है, कंडक्टेंस का फॉर्मूला पता है, उसका यूनिट याद रखो. ठीक है, मोलर कंडक्टेंस क्या होता है, इक्विवेलेंट कंडक्टेंस क्या होता है, स्पेसिफिक कंडक्टेंस क्या होता है. ठीक है, द कंडक्टेंस, मोलर कंडक्टेंस एंड इक्विवेलेंट कंडक्टेंस, दिस लाइन इज वेरी इंपॉर्टेंट. ओके, दे इंक्रीजेस विथ डाइल्यूशन, whereas specific conductance decreases with dilution. This line is very important. Conductance, molar conductance, equivalent conductance, their value increases as we dilute the solution. But for specific conductance, the value of what? It decreases with the dilution. Why? Because for specific conductance, we are constrained to a specific area. So as dilution increases, the charges present near to each other, they become separate by a longer distance. And that's why the specific conductance decreases. But for molar conductance, conductance and equivalent conductance, as dilution increases, their value also increases because more and more number of ions start to form, and their constant means more and more number of ions start to form because of the dilution, and that's why more ions, more conductance will be there, because the conductance will be carried by those ions. Okay, very important line. For strong electrolyte, if we need to calculate the conductance now, molar conductance, this is the formula, and this formula is known as Debye-Hückel-Ansager equation. You can draw the graph for this also. If you plot a graph of molar conductance against concentration, raised to half, that is under root of concentration, you will get a straight line. Okay, you will get a straight line. Okay, with the intercept equal to standard molar conductance, and their slope is equal to -1, minus a, sorry, not -1, minus a. Okay, so the graph linearly decreases with the change in the under root of concentration. Okay, this is the Debye-Hückel-Ansager equation. For weak electrolyte, as molar conductance increases, the concentration decreases, but does not reach a constant value, and that's why it is known as an infinite dilution. Okay, that is known as an infinite dilution. In order to determine the equivalent conductance for weak electrolyte, we need a Kohlrausch law. We use a Kohlrausch law, in which the equivalent conductance is nothing but it is the summation of the limiting equivalent conductance of a respective cations as well as their respective anions. That is what limiting equivalent conductance. These conductance contribute and they are called as limiting equivalent conductance at infinite dilution. Okay, so the above equation is however correct only for binary electrolytes like NaCl, MgSO4, etc. Okay, what are the applications of Kohlrausch law? So we can calculate the molar conductivity at infinite dilution for weak electrolyte. Okay, infinite dilution के लिए हम लोग क्या कर सकते हैं, molar conductivity calculate कर सकते हैं by using Kohlrausch law. Here I have shown for acetic acid, which is a weak electrolyte. You know that. Okay, so it's if you need to calculate its equivalent or molar conductance, you can just write down the limiting molar conductivity for acetate ion plus limiting molar conductivity for H+ ion. For strong electrolyte like sodium or potassium acetate, you can also calculate the molar conductivity for HCl, for KCl. Okay, so in order to calculate for weak electrolyte, okay, we need to form the equation like this way. और यहाँ पे पॉजिटिव निगेटिव करो, ठीक है. यहाँ पे देखो मैंने इक्वेशन 1 को इक्वेशन 3 में ऐड कर दिया, उसमें से इक्वेशन 4 मैंने रिमूव कर दिया, ठीक है, सब्सट्रैक्टेड. You get the equation number 1 and for that you get the molar conductivity value, right? Yesterday only we have solved the problem from the what question paper. Okay, you get the molar conductivity value for CH3COOH. Okay, next, you know there are two main very important electrolysis laws in the electrochemistry: Faraday's first law and Faraday's second law. So Faraday's first law suggests us that whatever the electrolysis takes place, okay, whatever the electrolysis reaction is going to happen in a given cell, the weight of the substance which is getting deposited on the electrode in a cathode will be directly proportional to the amount of electricity has been passed through a given solution, okay, in 1 second, okay, and that relation is like this way: W is equal to ZIT. Next, Faraday's second law, it states that when the same quantity of electricity is passed through a different electrolyte. See, A is electrolyte, B is another electrolyte, and C is another electrolyte. So when the same quantity of electricity is passed through these three different electrolytes, the quantity of deposition is directly proportional to their respective equivalent weight. So whatever is the equivalent weight of the given electrolyte, it will be depend upon that. Okay. Next, corrosion is the another topic present in electrochemistry. Rusting of iron, you should remember the rusting of iron. Where does the oxidation takes place? Where does the reduction takes place? And what are the reaction? Overall reaction you can see here. Okay, how we can prevent the corrosion? By coating the metal surface with the paint. Okay, by using a film of oil, by coating with the non-corroding material. Okay, next, very important, batteries. So batteries are what? Dry cell, mercury cell, lead storage battery, nickel cadmium battery, and fuel cell. So recently fuel cells questions are asked in examinations. Okay, which will be the anode, which will be the cathode, what is the electrolyte, and what is the E cell. So these are the different things you need to remember from this chart. Okay, try to remember this chart and try to solve the problems based on these batteries. Okay, you will be, if you solve 10 problems depending upon this chart, now you will be good to go and you will remember all the things present in this chart. Okay, next, let's solve certain problems of electrochemistry. Okay, we have very less time right now, but even though we will try to solve all the problems. Okay, first problem is the standard electrode potential of given cells are given to us. Okay, अल्यूमिनियम का दिया है सिल्वर, पोटेशियम एंड क्रोमियम. द करेक्ट डिक्रीजिंग ऑर्डर ऑफ रिड्यूसिंग पावर of each element is. So we have given different values for different electrode potential value we have given, and we need to calculate the reducing power. Okay, किसका decreasing order में है. ठीक है. So higher the value of E naught, stronger is the oxidizing power. Higher the value of E naught C, higher the value of E naught, stronger is the oxidizing power. We need a converse of that. So this decreasing order of reducing power of metal is K is more than aluminum, then chromium, and then Ag. So K का कितना है 1.66, 0.80, 2.93 and 0.74. So this is for aluminum, this is for Ag, this is for K, and this is for chromium. So higher the value, stronger is the oxidizing power. Okay, higher the value, stronger is the oxidizing power. So reducing power क्या होगी, उससे कम हो जाएगी. So our option here is what? Option B. Right? Next question. A button cell. Cell का प्रश्न है देखो. Button cell is used in watches function as. So we have given a reaction. Half potentials are like this way. What will be the cell potential? So you know the formula, E cell is equal to E oxidizing potential minus E reducing potential. Not minus, sorry, positive. Add both the electrode potential values, you will good to go, and you will get the E cell. So what is the answer here? 1.10. Okay, oxidizing potential plus reducing potential. How you will determine which is oxidizing potential and which is the reducing potential? So this is what gain of electrons. That's why it is what reduction. Here is what happening. 2 electrons are here in this side. Okay, you can Zn 2 plus 2 Zn. What is happening? 2 plus 2 0. There is a decrease in oxidation number. Decrease in oxidation number means what? Reduction. Here Ag2 to Ag. Here what is happening? Yes. Here also what is happening? All the potentials are written in what? Reduction potential values. Both are what? Reduction potential. तो यहाँ पे हमको फाइंड आउट करना है कौन सी रिएक्शन कैथोड पे हो रही है और कौन सी रिएक्शन एनोड पे हो रही है, और उससे हम लोगों को ऑक्सीडेशन पोटेंशियल मिलता है और रिडक्शन पोटेंशियल मिलता है. तो यहाँ पे ये दो जो रिएक्शन दिया हुआ है, यहाँ पे आप देख सकते हो कि दिस पोटेंशियल इज व्हाट एक्चुअली, दिस इज व्हाट ऑक्सीडेशन पोटेंशियल एंड दिस पोटेंशियल इज व्हाट रिडक्शन पोटेंशियल. और दोनों का मैंने सम करके ये आंसर लाया. नेक्स्ट फॉर द सेल रिएक्शन. सो यहाँ पे हमको सेल का रिएक्शन दिया हुआ है, ई सेल दिया हुआ है, and we need to calculate delta G. So you know the formula, delta G is equal to minus NF E cell. Okay, what is the value of N? N is equal to what? 2. Number of electrons involved are 2. So just put 2. F ka value you know 96500, that is Faraday's constant, and 0.24, and that E cell is given into the problem only. Calculate that, you will get the answer in joule, but you need to find out the answer in kilojoule. So that's why our answer here will be what? B. Okay. Yeah. Next problem. For a cell. Yes, for a cell. कौन सा सेल है? इन्वॉल्विंग 1 इलेक्ट्रॉन, 0.59 हम लोगों को इनॉर्ड सेल दिया हुआ है, हमको इक्विलिब्रियम कांस्टेंट दिया हुआ है, हमको ये जो हमारा पैरामीटर होता है नर्स्ट इक्वेशन में, that value is also given to us. We need to calculate what? We need to calculate the equilibrium constant. We need to calculate here equilibrium constant K. So here see the solution. E cell is equal to E naught of cell, the term log of QC. Okay, QC means what? Our reaction quotient. At equilibrium, you know what happens? E cell becomes 0 and reaction quotient becomes equal to the equilibrium constant. Just now we have talked about this. So E naught cell क्या हो जाएगा? It will be equal to 0.059 upon number of electrons into log of the equilibrium constant. So just put all the values 0.059. This is like this way. Transfer this term to this side. You will get here answer anti-log of 10. Okay, यहाँ पे क्या हो जाएगा? 0.59 divided by 0.059 equal to log of Kc. Right? Equal to log of Kc. Okay, just do the simple maths. Okay, यहाँ पे you will get the answer 10. यहाँ पे 10 होगा, यहाँ पे आएगा log of Kc, और log पे यहाँ पे ट्रांसफर करोगे तो क्या आप लोग को मिलेगा? एंटी लॉग ऑफ 10 is equal to Kc. So what will be the anti log of 10? You will get the answer, that is 1 into 10 raised to 10 anti Kc value. So the answer will be what? Option D. Yes, any doubt? सॉल्व करना था हम लोगों को, ठीक है? प्रॉब्लम सॉल्व किया है इस तरह से. Any doubt in this? Okay, next problem. In an electrochemical cell, Zn, ZnSO4, CuSO4, Cu, EMF of Daniell cell is E1. Okay, we have given these values. When the concentration is given, okay, concentration of ZnSO4 is changed to 1 molar and that of CuSO4 changed to 0.01 molar. The EMF changes to E2. E1 से कितना change हो गया उसका E2 change हो गया. From the following, which one of the relationship between E1 and E2 is true? So what will be the answer? So let's see here solution of this equation. E cell is equal to what? E naught cell. We need to use the Nernst equation. 0.059 divided by N log of Zn2 plus divided by Cu2 plus, because this is our Daniell cell. Product divided by reactant is our reaction quotient. We have given the concentrations of ZnSO4 as well as CuSO4. I have written the 0.01 and 1. Okay, when you find out E1 now, you will get here E1 is equal to E0 E naught minus 0.059 divided by 2. इसका आंसर आ जाएगा -2. ठीक है, when you calculate you will get the answer like this way, E naught plus 0.059. okay, what is E2? E2 is equal to E naught minus 0.059 divided by 2 log of 1 upon 0.01. यहाँ पे हमको दिखाया था क्या, when the concentration of ZnSO4 becomes 1 and that of CuSO4 becomes 0.01. यहाँ पे concentration हमको change करना था. पहले बार हमको concentration लेने थे 0.01 for zinc and 0.1 for copper. सेकेंडली ये बदल दो, क्या कर दो, जिंक का ले लो 0.1 और कॉपर का ले लो 0.01. ये बदलो, इसको बोलो E1, नीचे को बोलो E2. दिस इज E1 एंड दिस इज E2 एंड फाइंड आउट द रिलेशन. तो ये हमारा E1 हो गया, ये हमारा E2 हो गया. सो कौन सा वैल्यू ज्यादा है, यहाँ पे प्लस है, ऑब्वियसली दिस वैल्यू विल बी मोर, दिस इज माइनस, दिस विल बी द लेस. So that's why here what will be the answer, E1 will be greater than E2. Yes, E1 will be greater than E2, right? Any doubt in this? Good question. Okay, yeah, next problem. In the cell, E naught cell दिया हुआ है हमको, for a given reaction has a negative value. E naught का value क्या है, E naught cell is negative. Which of the following gives the correct relationship for delta G0 and K equivalent? Okay, and K equivalent. So यहाँ पे equilibrium constant जो है, K equivalent is what? K equilibrium constant. इनका क्या रिलेशनशिप हमको यहाँ पे करेक्ट लग रहा है वो हमको पूछा है. ओके, सो लेट्स कंसीडर हियर, या यू नो this equation delta G is equal to minus Na E cell, right? What we have given, E cell is negative. अगर E cell negative है, then delta G what will happen, if this is negative, the negative will become positive. So delta G will become positive. So it will be greater than 0. You know the relationship between delta G and equilibrium constant. What is the relation? Yeah, positive. Very good, Lakshmi. So what will be the delta G value? Minus nRT log of K equilibrium. So as delta G is positive, what will be the K equilibrium? It will be negative. So it will be less than 1. Okay. So यहाँ पे हम लोग क्या लिखेंगे? What is our correct answer? ABCD. Delta G is greater than 0 and K equilibrium is less than 1. Option A. Very good, Lakshmi. Next problem. Yeah, the pressure of H2 required to make the potential of H2 electrode is 0 in pure water at 298 Kelvin is. Okay, तो हमको पूछना है यहाँ पे कितना प्रेशर है अगर हमारा हाइड्रोजन रिक्वायर्ड इक्विलिब्रियम है, हाइड्रोजन पोटेंशियल इतना है, 0 है, तो क्या होगा? So you know pH for water is what? 7. Okay, so log of H plus, that is concentration of H plus ion, will be this much, 10 raised to minus 7. The reaction which takes place in hydrogen electrode is this one, 2H plus 2 electron gives H2. Let's write the Nernst equation for this equation. E cell is equal to E naught of cell minus 0.0591 divided by 2, that is number of electrons, log of pressure of H2, that is this product side, divided by reactant, that is H plus ions. दो थे, यहाँ पे मैंने वो रेस्ट टू लिख लिए. ठीक है, हमको क्या दिया हुआ है यहाँ पे, ई सेल क्या है, 0 है. ठीक है, इलेक्ट्रोड का पोटेंशियल कितना है, 0 है. ई नॉट सेल भी कितना है, 0. 0.059 log of pressure of H2 we don't know here, that is what we need to calculate. और concentration हम लोगों ने निकाला 10 raised to minus 7. Okay, 10 raised to minus 7. तो यहाँ पे माइनस साइन है. ओके, उसका स्क्वायर. सॉल्व करो ये प्रॉब्लम, ठीक है। लॉग ऑफ प्रेशर अपॉन दिस टर्म, यू विल गेट pressure is equal to 10 raised to minus 14 atm. Okay, 10 raised to minus 14 atm. Any doubt in this? Yeah, next problem. A hydrogen gas electrode is made by dipping platinum wire in a solution of HCl of pH equal to 10 and by passing hydrogen gas around the platinum wire at 1 atm at pressure. ऑक्सीडेशन पोटेंशियल ऑफ इलेक्ट्रोड वुड बी। तो हाइड्रोजन इलेक्ट्रोड का हम लोगों को क्वेश्चन पूछा है, हाइड्रोजन इलेक्ट्रोड में रिएक्शन कौन सा होता है, H2 गेट्स कन्वर्टेड इनटू 2H++ 2 इलेक्ट्रॉन, ठीक है। और यहाँ पे हम लोगों को ऑक्सीडेशन पोटेंशियल पूछा है। देखो यहाँ पे मैंने क्या किया है, H2H+ इज इक्वल टू E0 सेल क्या होता है हमारा, ऑक्सीडेशन हाइड्रोजन इलेक्ट्रोड का 0 होता है, तो 0.059 डिवाइडेड बाय 2 यूजिंग द नस्ट इक्वेशन, लॉग ऑफ प्रोडक्ट डिवाइडेड बाय रिएक्टेंट। प्रोडक्ट का कितना है 10 raised to minus 10, रिएक्टेंट का कितना है 1 atm प्रेशर। Just calculate it, you will get the value of oxidation potential for an electrode, that is option B. Right? Okay, next question. On electrolysis of dilute sulfuric acid using platinum electrode. यहाँ पे electrolysis हो रहा है dilute sulfuric acid using platinum electrode. The product obtained at anode will be. So during electrolysis of dilute sulfuric acid H2SO4, इसका क्या हो रहा है, electrolysis हो रहा है. So what will happen? The reaction, some will go to the cathode and some will go to the anode, right? Some will go to the anode and some will go to the cathode. So when electrolysis happen for dilute sulfuric acid, na, the reaction takes place like this way. Twice H2O gives O2 plus 4H plus and 4 electrons. So here E cell is what? 1.23 volt. So here O2 gets liberated at anode. What happens here? O2 gets liberated at anode, and that is what our answer here, option B. Okay, option B is our answer. Oxygen gas goes into the anode. So यहाँ पे हम लोगों को Faraday's का law use करना है। देखो, the number of Faraday is required to produce 20 gram of calcium from molten calcium chloride solution is, तो यहाँ पे 1 2 3 4, तो रिएक्शन देखो क्या होता है, Ca2 plus reacts with 2 electron to give calcium, ठीक है। यहाँ पे 2 इलेक्ट्रॉन मतलब 2 Faraday, ठीक है, 1 मोल 40 ग्राम, ठीक है, 1 मोल 40 ग्राम। लेकिन हम लोगों को क्या पूछा है, देखो 20 ग्राम के लिए पूछा है। सो 20 ग्राम के लिए कितने फैराडे लगेंगे, 2 फैराडे से अगर 40 ग्राम डिस्प्लेस हो रहे हैं तो 20 ग्राम के लिए कितना लगेगा, 20 ग्राम के लिए 1 फैराडे लगेगा। दैट इज व्हाट द आंसर, ऑप्शन ए। ओके, सिंपल। या नेक्स्ट, ड्यूरिंग द इलेक्ट्रोलिसिस ऑफ molten sodium chloride, the time required to produce 0.10 mole of chlorine gas using current of 3 amperes is. So here we need to find out the electrolysis of molten sodium chloride. Okay, and from that we need to calculate the time. So this problem is very means it requires more time. So see here what is happening. If you know the molten sodium chloride, if electrolysis happens now, what happens? At anode what goes and at cathode what goes. So when the electrolysis of molten sodium chloride takes place, at cathode sodium goes and at anode what happens, chlorine goes, Cl2 gas is liberated. So net reaction is like this way. So here you can see there are 2 electrons which are involved in this reaction. Okay, so according to first law of electrolysis, you know W is equal to ZIT and time we need to calculate. So weight is equal to what? Equivalent weight divided by Faraday's constant into I into T. So number of Cl2 gas into molecular weight of Cl2 gas, okay, is equal to what? Equivalent of that Cl2 gas into I into T divided by 96500. ठीक है, weight मतलब क्या होता है? Weight is what? Number of moles, right? Number of moles, right? So into molecular weight मैंने यहाँ पे किया हुआ है। तो मैंने W is equal to E upon 96500 multiply by I multiply by T, ठीक है। तो यहाँ पे वेट क्या होता है हमारा, यू नो द फॉर्मूला, नंबर ऑफ मोल्स इज इक्वल टू वेट अपॉन मॉलिक्यूलर वेट। तो मैंने वेट के लिए फॉर्मूला लिख लिया, नंबर ऑफ मोल्स इनटू मॉलिक्यूलर वेट यहाँ पे, ठीक है। तो नंबर ऑफ मोल्स इनटू मॉलिक्यूलर वेट is equal to equivalent weight upon 9650 I into T. तो I का वैल्यू दिया हुआ है 3 एम्पियर, ठीक है। T का वैल्यू हम लोगों को कैलकुलेट करना है। हमारे पास नंबर ऑफ मोल्स दिए हुए हैं, कितने मोल्स है, 0.10 मोल्स, ठीक है। और मोलिकुलर वेट Cl2 गैस का यू कैन कैलकुलेट। So just solve this equation, you will get the answer in terms of second. Convert that second into minutes, okay, you will get your answer 110 minutes. Yeah, any doubt in this? Yes. Okay, any doubt in this? Okay, next problem. The number of electrons delivered. Okay, the number of electrons delivered at cathode during electrolysis. Cathode पे कितने electrons क्या हो रहे हैं? Deliver हो रहे हैं when 1 ampere current is passed 1 ampere in 60 seconds. Okay, 1 ampere current is passed in 60 seconds. So how many number of electrons are going to displaced or delivered at the cathode during the electrolysis process? So see here, Q is equal to IT. Okay, Q is what? Number of Q is what? Coulomb, electricity. Okay, not charge. Q is what? Charge, not electricity. Q is what? Charge. Charge is equal to I into T. I क्या है हमारा 1 ampere, T क्या है हमारा 60 second. This much is the charge which can be displaced. Okay, and charge on electron given कितना है 1.60 into 10 raised to minus 19 coulomb. तो 60 को multiply कर दो 1.6 into 10 raised to minus 19 से you will get your answer. कितना आएगा आंसर? ऑप्शन यस ABCD करो, चार्ज को कंसीडर करो. यस, यहाँ पे आंसर आ जाएगा 3.75 into 10 raised to 20. ठीक है, एक इलेक्ट्रॉन का चार्ज इतना है. ठीक है, तो इतने चार्ज पे कितने इलेक्ट्रॉन्स होंगे डिस्प्लेस? तो इतने इलेक्ट्रॉन्स डिस्प्लेस होंगे. एनी डाउट इन दिस? क्रॉस मल्टीप्लीकेशन करना है. Okay, next, the device that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy. So this cell is very, very important. It is known as a fuel cell. Okay, which converts energy of combustion of fuels, whatever the fuels are present, hydrogen, methane, directly into the electrical energy, and that's why it is known as a fuel cell, because here we use the fuels, okay, in order to produce the electricity. Next, the efficiency of fuel cell is given by, not deficiency, sorry, efficiency. So efficiency means what? How much is the efficiency of a given fuel cell? So fuel cell, we have seen that combustion of fuels like hydrogen and methane to produce the electrical energy. So how we can say that a fuel cell is efficient or not? So in order to determine their efficiency, we need to consider that for a thermal efficiency, fuel conversion device is the amount of useful energy produced relative to the change in the enthalpy. So useful energy produced relative to the change in the enthalpy. So in this case of electrochemical converter, for a fuel cell, change in gas free energy for a reaction is available as a useful electrical energy. Okay, that is available as a useful energy. That's why our efficiency eta will be equal to delta G upon H. Our eta will be equal to what? Delta G upon H. Okay, so that's why what will be our answer? Correct option is what? B. Right? Correct option is what? B. Any doubt in this? Efficiency कैसे निकालोगे? Useful energy divided by delta H. Next question. Yes, zinc can be coated on iron to produce galvanized iron. See, corrosion. We have talked about corrosion, right? For corrosion, how we can prevent the corrosion? Coat it with the different type of material. Paint the surface of the material. Or you can use different type of foils to cover a given iron molecule. Okay, iron material. So यहाँ पे क्या हो रहा है? Zinc can be coated on iron. यहाँ पे zinc coat किया है iron पे to produce galvanized iron. But the reverse is not possible. Why? So you can coat zinc on iron bar, but you cannot coat iron on zinc bar. Why is that? Because zinc is lighter than iron. Zinc has lower melting point than iron. Zinc has lower negative electrode potential than iron. Zinc has higher negative electrode potential than iron. So when I have told you about the electrochemical series now, so in electrochemical series, the elements are arranged in such a way that increasing their reducing potential. Okay, so reduction potential for zinc is 0.76, but for iron it is 0.44. So who is having the highest negative electrode potential value? So zinc is having highest negative potential value, and that's why it cannot be on which iron cannot get coated. Okay, because it is having a higher negative electrode potential than iron. Iron cannot be coated on zinc. जिसका ज़्यादा होगा, that is our answer is what? Option D. Zinc has higher negative electrode potential than iron. and that's why we cannot quote it, because iron is more prone to undergo into oxidation as compared to zinc. आयन पे सबसे ज्यादा पहले हो जाएगा, ठीक है, जिंक से, इसलिए हम लोग जिंक पे आयन नहीं कोट कर सकते, लेकिन आयन पे हम लोग जिंक कोट कर सकते हैं क्योंकि उसका जो रिडक्शन पोटेंशियल वैल्यू है वो ज्यादा है, ठीक है, नेगेटिव रिडक्शन पोटेंशियल वैल्यू जो है वो उसका ज्यादा है, इसलिए हम लोग वो कोट कर सकते हैं. आयन का जो वैल्यू है दैट इज लेसर, दैट्स व्हाई वी कैन नॉट कोट ऑन इट. You can see the values also 0.76 and 0.44, right? Okay. Next, okay. So thank you so much for joining in. If you have any doubts, you can talk to me. Yes, you have any doubts? Thank you, Lakshmi. Thank you for joining in. Yes, thank you. If you have any doubt, you can ask. Okay, thank you. Yeah. So I will end this meeting. Tomorrow, let's meet on the same timing for a new chapter. That is, we are going to talk tomorrow about the carboxylic acid topic. Okay, try to read about that. Okay, we will solve PYQs as well as we will learn about, we will revise the chapter. Okay, we will revise the topic of carboxylic acid. We will see the preparation as well as chemical reactions of carboxylic acid. To try to revise those things, and if you need any explanation about any topic, you can tell me. Okay, chalo. So let's end this session. Bye bye.